everyone, today we're doing 5.3, writing linear equations using 2 points. Okay, so we have to write the equation of a line, and we're given 2 points, 0, 0, and -2, -2. Recall from 4.4 when we learned the slope equation. So our slope, m, can be found with the equation y2 minus y1 over x2 minus x1. This is going to come in handy as we work through these problems. So in 5.2, we learned how to find the equation of a line given a point and a slope. In this case, we are only given 2 points. We aren't given the slope, we aren't given the y-intercept or anything. So we're going to have to find all of that ourselves. So we're going to start with the slope. Let's label our 2 points. We'll call 0, 0, x1, y1, and the point -2, -2, x2, y2. So now we can just take that information and plug it into our slope formula. So our slope would be y2 minus y1. Our y2 value is -2, and our y1 value is 0. So we have -2 minus 0 over our x2 is -2, and our x1 is 0. So we have -2 minus 0. So -2 minus 0 is just -2. Our slope is going to be -2 over -2, but anything over itself is just 1. So our slope will be 1. Now this problem just becomes what we've been doing before. We have a slope, we have a point, so we can just plug everything we know in and solve for b. And with these ones, what you want to do is just pick one point from the 2 they give you and plug it into your equation. So we're given the point 0, 0, so I'm going to go ahead and use that. So 0 is our y. Our m is 1, our x is 0, and we'll figure out our b. Anything times 0 is just 0, so we have 0 equals 0 plus b. So b is 0. So now we have our slope, we have our y-intercept, so our equation would be y equals 1x, which is just x, plus 0. So there's our equation. Go ahead and pause and see if you can do the next one on your own. So we'll go ahead and label these guys. x1, y1, x2, y2. Plugging into our slope formula, we have our y2 minus y1, which would be 1 minus 3. And our x2 minus x1, which would be 5 minus 1. So in the numerator, we have 1 minus 3, which would be -2. In the denominator, we have 5 minus 1, which would be 4. And then we can simplify this a little bit further. 2 over 4 is the same as 1/2, so our slope would be -1/2. Now we need to pick which point we're going to use to plug into our equation. I'm going to go ahead and pick 1, 3. You can pick 5, 1 if you want, it doesn't matter. So we'll plug in what we know, solve for what we don't know. We know our y value is 3. We know our slope is -1/2. We know our x value is 1, and we'll figure out what b is. So we have 3 is -1/2 times 1 is just -1/2 plus b. Then we have to solve for b. So the opposite of -1/2 would be adding 1/2. So we'll add 1/2 to both sides. So on the left we have 3 plus 1/2, and on the right we have b. We can't just add 3 and 1/2. We need to make sure our 3 has a common denominator. So we'll have to multiply our 3 by 2 over 2. So we get 6/2 plus 1/2 is b. So our b value would be 7/2. So now we know our b, we know our m, and we can just plug it in. Y equals -1/2 x plus 7/2. And there's our equation. In the next example, we're asked to give the slope of a line perpendicular to the given line. In our previous lessons, we've looked at what it means for a line to be parallel, but we haven't necessarily looked at what it means to be perpendicular. So we'll take a second and do that. So 2 lines are perpendicular if their slopes are opposite reciprocals. So an opposite reciprocal means we're going to take whatever our slope is, we're going to flip it around and make it negative. So for example, if we had a slope of 1/2, then if we wanted to find a slope perpendicular to that, we would flip our fraction and then we make it negative. So our slope would become m equals 2/1, which we can just write as 2, and then we tack a negative on the front. Another example would be if we have a slope of -3. We want the opposite reciprocal of -3. Remember, -3 is technically -3/1, so if we wanted to flip that, our slope would become 1/3, but then we need to make it negative. So a negative times a negative would just be a positive, so our perpendicular slope would be positive 1/3. So again, opposite reciprocal means flip the fraction and make it negative. And if it's already negative, then we make it positive. So let's look at these examples. We have to find the slope of the line perpendicular to the line we're given. So in A, we're given the line y equals x plus 1. And we know there's technically a 1 implied in front of this x. So that means our slope would be 1. Now the opposite reciprocal of 1, if you remember, 1 is technically 1/1. So we got to flip that. So 1/1 flipped is still 1/1, or 1. And then we make it negative. So this would be the slope of a line perpendicular to y equals x plus 1. In B, we're given the line y equals -1/2 x minus 1. So our slope in this one will be -1/2. And so a slope perpendicular, we have to flip that fraction and then change the sign. So we flip the fraction, it becomes 2/1, which is just 2, and then we flip the sign, so it becomes positive. So positive 2 would be our slope. Finally, we have y equals 2x, so our slope here is 2, which we know is 2/1. So we gotta flip that and change the sign. So our slope would be 1/2, and then make it negative. -1/2. And that's it for Chapter 5. Next we're going to be shifting gears and looking at Chapter 8, which is all about properties of exponents.